We're constantly hearing about the urgent need for, a sustainable future. But what if the way we actually learn about our world, those maps, the data, how we see things, could be actively shaped by the learners themselves?
Hmm.
Imagine using all this cutting edge tech not just as a subject, but like as a toolkit for students to build their own understanding of the planet's challenges and, maybe more importantly, the solutions. Okay, let's kind of unpack this.
Yeah, what's really exciting here, I think, is this whole hands-on philosophy that's cropping up in education, specifically around spatial computing for sustainability.
Right.
We're seeing this curriculum emerge that's designed quite deliberately to be of the faculty and students, by the faculty and students, for the faculty and
Oh,
students.
that phrase again, it really captures it.
It does. It's not your typical top-down thing. It's much more about collectively building knowledge, from the ground up.
Exactly. And for anyone listening who's maybe wondering, spatial computing, what's that? It's not just about making cool digital globes, is it?
No, not at all. Fundamentally, it's about looking at spatial relationships.
Yeah.
So how we interact with our surroundings,
Mm.
how we represent them, how we change them both digitally and physically.
So think geospatial data, obviously, but then layering on things like world building to picture possibilities, simulations to see like the impact of changes.
Gamification even to get people engaged.
Yeah. And digital twin modeling, making these virtual copies of real places or systems. This is where it gets really interesting, I think.
And if you connect this to the bigger picture, this whole approach uses some incredibly powerful tools.
Like what?
Well, things like QGIS for the mapping and analysis side, Blender for creating 3D models, game engines like Unity and Roblox for making interactive environments,
Wow.
and platforms like Spatial.io for these shared digital experiences. It's quite a toolkit for tackling something as complex as sustainability.
And it's not just theory, right? This whole learning experience is being shaped by people like Dr. T.H. Culhane, who's a National Geographic explorer. He sort of embodies that hands-on investigation spirit.
Right. It's that idea of learning sustainability the National Geographic way.
Hmm.
Get out there, explore using these digital and physical tools, and then report back, share what you find.
So the curriculum is genuinely being co-created.
Exactly. Which brings us to a really key question. How do we move from just like passively absorbing info about sustainability to actively engaging with it, maybe even influencing how we understand it?
Yeah.
This model of education seems to offer a pretty direct way to do that.
Absolutely. And a big idea driving this seems to be democratizing the knowledge and the tools. The resources we've looked at really stress making geospatial planning more accessible, pushing for evidence-based decisions, and getting people to work together, putting these powerful tools in more hands.
And what's really significant, I think, is the focus on cost-free and open source tools. QGIS, Blender GIS, Unity, Roblox Studio, Cesium Ion, Spatial.io. None of these need expensive licenses.
That's huge.
It totally levels the playing field. It empowers people, regardless of their budget, to visualize and maybe even start implementing sustainability solutions where they live. It's not just saving cash. It's about getting more people involved in shaping a sustainable future.
And there's that great story about Lisa Le Senior, the student from France.
Yeah.
Initially, she thought all this tech was just way too much, too intimidating. But through actually doing it, hands-on, she got confident enough to use these tools for sustainable tourism projects. It really shows these aren't just for the tech gurus. They're for anyone with that passion,
It totally underscores that. And it ties right into those courses mentioned, like Envisioning Sustainability and the Sustainability Design Laboratory.
Right, the USF ones.
Yeah. Those are real-world examples of this collective curriculum development happening right now. It's this dynamic space where everyone, faculty, students, they're all learning and building together continuously.
Now, something that really grabbed me was the part about spatial thinking and our internal mental maps. This goes beyond just the technical side of GIS, doesn't it? It gets into how we psychologically see and deal with the world.
It's fascinating, isn't it? The idea that how we internally understand space really shapes our experiences, our actions, even our sense of well-being or suffering.
Wow.
And this curriculum explores how maybe by reimagining and representing the world differently, we could brief some divides. Think about recognizing how all those different types of capital money, skills, connections, culture, things we make, nature, how they're all linked, how they all add up to our well-being.
That's a really powerful lens, and the examples they give are compelling, like Medellin,
Yeah.
Colombia.
Yeah, amazing story.
A city turning itself around from a really tough past towards sustainability, using GIS as a core tool.
Mhm.
And then the Amazigh people in Morocco using GIS to sort of reclaim their own story, their history, after colonialism.
It's incredibly powerful. It's about communities using these tools to define their own narrative, their own future on their terms.
Yeah.
And that ties into the geographical vitae concept, the GV.
Right, using the cesium ion story maps.
Exactly. Learners map and share their own places, the environments that shape them, and reflect on the psychological impact. It's a really personal starting point for exploring spatial relationships.
So we're building this foundation in spatial thinking, and then the curriculum gets practical with hands-on GIS, specifically QGIS.
Yeah.
Starting simple, like adding a base map. We all know Google Hybrid.
Yeah, it's smart. It bridges that gap between everyday map apps and the more professional GIS world. Makes it less scary.
Totally.
Then they dive into the essentials. Coordinate reference system, CRS, how we get the round Earth onto a flat map.
Ah, the projections.
Exactly.
Yeah.
And they talk about Mercator, Peters, Robinson, how each one changes how the world looks. You know, why Greenland looks huge on some maps. That's the projection.
Right, the material even jokes Mercator magnifies near the poles. And Peters plays fair with area, even if shapes get weird. Robinson tries for a balance.
Yeah, understanding those distortions is key. Then they cover geocoding, finding places easily, and the quick OSM plugin.
Oh, that's super useful. Accessing all that OpenStreetMap data.
Roads, buildings, points of interest, instantly available. And XYZ tiles for adding other web maps.
And then getting into layers and attribute tables, understanding a map isn't just one picture, but stacks of info.
Exactly. And each bit of info, each feature on the map, has data attached to it in the attribute table. They even make a distinction between the landscape, the more permanent stuff, and attributes, which are like the characteristics or opportunities a place offers.
So the attribute table is basically the database behind the map.
Pretty much. You can store info there, change it, analyze it, accessibility, what kind of plants are there, infrastructure, whatever's relevant.
And this data isn't stuck in QGIS, right? The curriculum really pushes using simple spreadsheets, CSV files for sharing.
Oh, absolutely. CSVs are like the universal translator for geospatial data, super important for collaboration.
Makes sense.
And they mention free tools like LibreOffice Calc for handling that data. It even nods towards R and RStudio for more heavy-duty stats and mapping, mentioning packages like SF and ggplot2.
So you could take data from just a basic spreadsheet and suddenly see it spatially in QGIS.
Exactly. And the curriculum walks you through that. It shows how even simple data gets way more insightful when you put it on a map.
That's cool.
And then you can enrich those maps further with attachments.
Like photos and videos.
Yeah, photos, videos, documents, whatever, linked right through the attribute table. And using web links makes it way easier to share everything. Anyone with a QGIS project can click and see the related media.
Okay, so that naturally leads into making things 3D, right? Moving beyond the flat map.
The curriculum brings in tools for that, like Blender GIS, integrating cesium ion right into QGIS, even Google photorealistic tiles. It's a big step towards more immersive visualization.
Bringing the data to life.
Totally. But working with big 3D data sets needs some setup. So the curriculum covers optimizing QGIS, adjusting project areas, cache settings for cesium data, that kind of thing.
Practical tips.
Very. And using digital elevation models, DEMS, which are basically 3D terrain data. Plus plugins like QG3JS to actually build those 3D views inside QGIS, like a digital landscape model.
And the link between Blender and QGIS seems pretty strong, too.
Yeah, they show how to bring 3D objects made in Blender into QGIS as map symbols. There's a key tip about zeroing out the object's origin point in Blender so it shows up in the right spot on the map.
Ah, gotcha.
And the Blender GIS add-on lets you pull geospatial data directly into Blender for more detailed 3D modeling.
You can even do things like solar analysis.
Yep, using the sun position add-on in Blender. You can simulate sunlight and shadows realistically on your 3D models. Super useful for sustainable design, like figuring out solar panel placement or building orientation.
Okay, and then pushing beyond just looking at 3D models to actually interacting with them.
Right. Platforms like Spatial.io and Roblox Studio come into play here, creating virtual spaces where people can engage with these 3D environments.
You mentioned Unity, too, but Roblox seems maybe better for education.
Well, Unity is incredibly powerful, used by pros. But the curriculum notes Roblox Studio's ease of collaboration and publishing. It makes it potentially a better fit for educational digital twins, where students need to easily work together and share what they build.
Makes sense for that collaborative, student-driven approach.
Exactly. And finally, it touches on point clouds, usually from LiDAR scans.
That super detailed 3D data.
Yeah, incredibly detailed. They introduced tools for handling a QGIS with extensions like LS tools and PDAL, Cloud Compare, Blender with specific add-ons, and understand the classification codes like knowing ground is usually code 2, vegetation 3 to 5, building 6. That helps make sense of the data.
And then bridging digital and physical, again, 3D printing.
Yes, using the DEM to 3D plugin in QGIS to print topographic models from the GIS data, taking that digital landscape analysis and making it something real, something you can actually hold.
Wow. Okay, so pulling this all together, what does it really signal?
I think it signals a pretty profound shift in sustainability education. It's moving away from just, being told about problems
Mm-hmm.
to actively creating, exploring, simulating potential solutions using these really powerful, accessible tools. It's about empowering people.
Giving them the skills and the knowledge, not just to understand the complexity, but to actually be agents of change.
Exactly. It's genuinely empowering.
Absolutely. And by embracing this hands-on, student-driven way truly of the faculty and students, by the faculty and students, for the faculty and students, this curriculum fosters learners who aren't just informed, but are actually equipped to help shape that sustainable future.
hmm Which leaves us with a final thought maybe for
Yeah.
you listening. As our digital and physical worlds keep merging, just think about the potential for working together on sustainability problems in new ways.
Yeah.
How might you use some of these ideas, these tools, in whatever you're interested in to help bridge that gap and make some real change in the world around you?